Welcome to the Machine Learning Taster session. In this session, we're going to talk about the Bootcamp's prerequisites, an introduction to machine learning, and an overview of the type of content that will be taught on this bootcamp. So the prerequisites are that you have not taken a DFE bootcamp from Bothsport or another provider within the last year, and you are familiar with programming and its core concepts. So while we will be using Python while doing this bootcamp, it's not essential that you know Python. It's just more that you are familiar with understanding what functions are, what if statements are, and so on like that, and our willingness then to learn Python as well. So is this bootcamp environmental or skills focused? So while the bootcamp has an environmental theme, the focus is on teaching you core ML skills that are transferable across multiple sectors. So where a field needs a data scientist, the need for the skills will be also required that we'll be teaching on this bootcamp. So the topics we'll be covering will be supervised learning, unsupervised learning, reinforcement learning, natural language processing, and we'll also be teaching you how to deploy models into production. There will additionally be an in-person workshop provided by the data place. So what is machine learning? Machine learning is the science and art of programming computers so they can learn from data. So a definition would be machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. However, a more engineering or orientated one is a computer program is said to learn from the experience E with respect to some task T and some performance measure P. If it is performance on T as measured by P improves with experience of E. So what is machine learning? So your spam filter is a machine learning program that, given examples of spam emails, for example, flagged by users, and examples of regular non-spam, also called ham emails, can learn to flag spam. The example that the system uses to learn are called the training set. Each training example is called a training instance or sample. In this case, the task T is to flag spam from the new emails. The experience E is the training data, and the performance measure P needs to be defined. For example, you can use the ratio of correct classified emails. This particular performance measure is called accuracy and is often used in classification tasks. So for example, if you download a copy of Wikipedia, your computer has a lot more data, but it's not suddenly better at any task. Thus, downloading a copy of Wikipedia is not machine learning. So why use machine learning? So consider how you would write a spam filter using traditional programming techniques. So you would, so what you would have done traditionally is you might have noticed some keywords like such as for you, credit cards, free, and amazing tend to come up a lot in subject lines. Perhaps you would also notice a few other patterns in the sender's name, the email body, and other patterns on the email. You would write a detection algorithm for each of the patterns that you noticed, and your program would flag emails as spam if a number of these patterns were detected. You would test your program and repeat steps 1 and 2 until it was good enough to launch. Since the problem is difficult, your program will likely become a long list of complex rules, pretty hard to maintain. In contrast, a spam filter based on machine learning techniques automatically learns which words and phrases are good predictors of spam by detecting unusual frequent patterns of words in the spam examples compared to the ham examples. The program is much shorter, easier to maintain, and most likely more accurate. So what if spam was noticed that all the emails containing for you are blocked? They might start writing for you instead. A spam filter using traditional programming techniques would need to be updated to flag for you emails. If spammers keep working around your spam filter, you will need to keep writing new rules forever. In contrast, a spam filter based on machine learning techniques automatically notices that for you has become unusually frequent in spam flagged by users and starts flagging them without your intervention. Another area where machine learning shines is for problems that either are too complex for traditional approaches or have no known algorithm. For example, consider speech recognitions. Say you wanted to start simple and write a program capable of distinguishing the words 1 and 2. You might notice that the word 2 starts with a high-pitched sound T. So you could hard code an algorithm that measures high-pitched sound intensities and use that to distinguish ones and twos, but obviously the technique will not scale to thousands of words spoken by millions of different people in noisy environments and in dozens of languages. The best solution, at least today, is to write an algorithm that learns by itself, given many examples, recordings for each word. Finally, machine learning can help humans learn. ML algorithms can be inspected to see what they have learned, although for some algorithms they can be tricky. For instance, once a spam filter has been trained on enough spam, it can easily be inspected to reveal the list of words and combinations of words that it believes are the best predictors of spam. Sometimes this will reveal unsuspected correlations of new trends and thereby lead to a better understanding of the problem. Applying ML techniques to dig into larger amounts of data can help discover patterns that were not immediately apparent. This is called data mining. So let's see some code in action. So the first thing I'm going to do here, I'm going to import all the libraries that I need to complete this task. Then I'm going to load up a CSV file and save it within my Boston variable to hold all the data I require. So if we just have a little interrogation of the data, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different features. And overall, then we have a lot of values within that. So this command here is only showing me the top 5. So what I'm going to do is I'm going to take my Boston data set and I'm going to drop this final column because that's what I want my target to be, so what I'm trying to predict, and I'm going to have that all be within the X value, so creating the feature. I'm then going to have then this last feature to become a Y, which is going to be my target value. So here now I am taking a X rooms variable, which I'm going to take my data set of a X, my features, and I'm just going to take the 5th column with all the values within that. So we got 0, 1, 2, 3, 4, 5. So we're taking this one here, which is the room number. I'm then going to reshape my data and to make sure that it fits into my model as required. And here I'm going to visualize my data. So here we can see we've got the number of rooms across the bottom against the value of the houses. So now I'm going to start making my model. So what I'm doing here is I'm taking the linear regression class and then I'm assigning that to the variable model. And now what I'm going to do is fit that model. So I'm going to take the X rooms as my data, and then my Y is my target. So here all I'm doing is creating a line space to help then with the predictions. So I'm going to now create another scatter graph here where we're going to take our predictive space and then we're going to do a model predictive against that, and then we're going to see where it's predicted against. So here we can see that these are the data that we had, and then this here is our linear regression based prediction line. So that's where if we was to have, say, 6, predict 6, it would give us the value 20. Thank you for watching this taster session, and I look forward to meeting you on our course.